Okay, let us continue with our second calculation. So now we will be calculating a distance. You guys will be calculating a distance. It's a pity you are not able to see the map that I'm using, but I'm going to just draw for you guys a diagram that is more of the same that you'll be using in your exam. So now we will be calculating our distance. So again, let me just give you, let's say here's our trick beacon, and then our trick beacon here, maybe it's 960, and then 960, and then we have a spot height. Here is our spot height here, and then let's just give it 391. Okay, so when we are calculating the distance, we first join the two lines. From the trick beacon to the spot height. So we measure between the trick beacon, the distance between the trick beacon and our spot height. The spot height, which is 391, and our trick beacon, which is 960. So we are going to measure the distance between these two spot height, our trick beacon and the spot height. Let's just say the distance between this trick beacon and this spot height is just 3 centimeters. The distance from this spot height to this trick beacon, it's just 3 centimeters. Okay, we are going to calculate an area. We are going to calculate the distance. So now, the formula to calculate the distance, this is our number 2. We are calculating what? The distance. We are calculating the distance. And the formula to calculate the distance, it is map distance. Map distance multiplied by the scale. So now we are going to calculate the map distance of these topographical map again. Let us use a topographical map again with the scale of 1:50,000, but we are going to calculate the map distance in meters. We are going to calculate the map distance in meters using the map topographical map. Okay, so now let us calculate what is our map distance. The formula says map distance multiplied by what? By the scale. So now, what is our map distance? Here is our map, the map distance. We have measured our map distance that from this spot height to this trick beacon, it is what? It is 3 centimeters. So that means our map distance is 3 centimeters. And then now we are going to add our scale. What is our scale? We're told that to calculate the distance from the spot height to the trick beacon using a topographical map. So now in kilometers, this is in kilometers. Do not be confused, we are calculating in kilometers. Okay, now again, as we know, we have calculated before that when we are moving from centimeters to kilometers, you divide by what? By 100,000. And we know that 50,000 centimeters divided by 100,000, that is equal to 0.5 kilometers. So that means our scale is going to be 0.5 kilometers. So we are calculating what? Our distance. So we were calculating in kilometers. Now take your calculator and punch. We are going to say 3 multiplied by what? 0.5 kilometers. And then what the answer we're going to get, it is 1.5 cm. So this is our distance. This is how we calculate our distance. Okay, let us take another example when we are calculating the distance. We are going to use the same information that I've given you. We are going to use the same information that I've given you, this one. We are going to use the same, but now we are going to calculate the distance in meters. If the examiner is asking you to calculate the distance in meters. So if we were asked to calculate the distance in meters, we were going to say distance, the D stand for distance, is equal to MP, which is, MD, in fact. It's going to be MD, which is the map distance. I'm abbreviating because of time. Multiplied by what? Multiplied by the scale. And then we are going back. What is our map scale? It is 3 centimeters. And then we are going to write our 3 centimeters. And then we are going to multiply. We are now calculating in meters. In meters. We are now calculating the distance in meters. So now again, we need to apply our conversion. Let us go back to our table that we used for conversion. We are moving from centimeters to what? To meters. So when you are moving from centimeters to meters, you are going to divide by what? By 100. Because we are going to have what? We're going to have 1 here. We are going to have 1 and then 0, the first 0, and then there we go. We are at the meters. That means we are going to divide by what? By 100. Now we are going to say 50,000 centimeters, the original scale, divide by what? By 100 to get the scale of a topographical map in meters. And then I hope you got the same answer, which is 500, which is 500 meters. So now, as we are calculating in meters, we are going to say 3 centimeters multiplied by what? 500 meters. And then we are going to get our 1.5 centimeters. Meaning that in meters, when we are calculating in meters, our distance is going to be 1,500. And when we are calculating in kilometers, it's going to be what? 1,5 centimeters. All right. I hope you guys have understood how to calculate the distance. All right. Now, let us move to our third calculation. We are now moving to our third calculation. We'll be calculating our gradient. We are going to calculate the gradient. We're going to calculate the gradient. Before we move to calculate a gradient, when we are calculating the distance, you can use 3 things. You can use your ruler to measure the distance between the trig beacon and the spot height. You can use a ruler, that is number 1. Again, you can use also what? The string. You can use the string. You can use the string also to measure the distance between the two. So, but the string that you can use, you must use a type of a string that does not stretch. Like this is is a wire of my headset. We use a string that does not stretch, and then you measure on top of the line the distance, and then obviously you are going to take that measurement, and then you are going to place it on your ruler, and then to get the actual distance between the 2 points. So you can use a string or you can use your ruler if it is just a straight line. But if it is a line that has the bends, I encourage that you guys use a string, but a string that does not stretch, and then you are going to place your string on top of the line from point A to point B, and once you have measured, you are going to take that string, that measurement that you have got, and then you place it on your ruler. And when you place it on your ruler, you are going to write that measurement that is written on your ruler. Okay, so another method that you can do, that you can use, it is a paper method. You can also use a paper method whereby you are measuring from point A to point B. Okay, So we are going to be using, we will be doing that, those two methods, the string method and also the paper method on our next lesson. But today, I want us to focus mostly on this ruler thing. All right. Now, let us calculate. We will be calculating now our gradient. Our gradient. We'll be calculating the gradient. For gradient, we'll be calculating, our next calculation is going to be on gradient. So the formula to calculate gradient, it is vertical interval. The VI stands for vertical interval, divided by what? The horizontal distance. The horizontal distance. So when we are calculating a gradient, we are using this formula, the vertical interval divided by what? The horizontal distance. Okay, so now, again, let me just draw for you. We are calculating a gradient of this box. Again, have this box here, and then we have a trig beacon again, which is 960, and then we have what? Our spot height here. Let me just say it is 500, and then here is our trig beacon. So when we are calculating the gradient, we first calculate the vertical interval. We first calculate the vertical interval. So when we are calculating our VI, our vertical interval, we subtract the bigger number with the smaller number from the information at the box or from the map. From point A to point B, you subtract the bigger number with the smaller number. For instance, here we have 960 and then we have 500. So when we are calculating, we are saying bigger number, but you guys shouldn't write this on your exam. I'm just making it so it's easy for you. Bigger number, and then minus by small number. Okay, so let us join our two lines, the trig beacon and the spot height. Okay, so what is the big number? Our trig beacon is 960. That is our biggest number, and then our spot height is 500. So we are going to say 960 minus 500, and obviously we are going to get 460. That means our VI is 460. So when we are calculating our vertical interval, we say the biggest number minus the smallest number, of which is 960 minus 500. Okay, now again, let us move on, because the formula says it is VI, vertical interval, divided by horizontal distance. Let us now calculate our horizontal distance. So when we are calculating our HD, our horizontal distance, we say, when we are calculating our horizontal distance, we say map distance. Map distance, we multiply by the scale of the map. So let us assume that we are using a topographical map. Topographical map. And then we know the scale of the topographical map, that it is 1:50,000. But we are going to calculate using the scale of a topographical map, and let us assume again that we are going to calculate this gradient in meters. We are going to calculate in meters. Okay, so now here is our formula. Let's come back to our formula. It says when we are calculating the horizontal distance, it's say the map distance multiplied by the scale. So where is our map distance? When we are measuring our map distance, we measure the distance from point A to point B, from the 2 points, from the trig beacon to the spot height. We measure from the trig beacon to the spot height. What is our spot height? It is 500, and then what is our trig beacon? It is 960. So we measure the distance between these 2 points. We measure the distance between these 2 points, and then let us assume we got 3 centimeters. We got 3 centimeters, and then we are going back to our calculation. And then what our map distance, it is 3 centimeters multiplied by, what is our scale? We are calculating our horizontal distance in meters. So you guys know that the conversion that we use, that when we are converting from centimeters to meters, you divide by 100. So we are going to say 50,000 centimeters divided by 100 meters, and then we are going to get 500. That means our scale is going to be 500 in meters, and then we are going to say 3 centimeters multiplied by 500 meters, and then we are going to get what? 1.5 centimeters. And then now that we have calculated our vertical interval and also the horizontal distance, we are now going to calculate, we are now going back to our formula, which says gradient equal to VI. Our G, which stands for gradient, equal to VI divided by what? HD. Now, let's come here. What is our VI? Our VI, here is our VI. We have calculated our VI, our vertical interval. It is 460. Now, we are using the formula that we are given. Then our VI is going to be 460. And then obviously, what is our horizontal distance? We are following this formula. Our horizontal distance is 1,500. It is 1,500. So when we are calculating the distance, we are now going to represent it on a ratio scale. We are going to represent it on a ratio scale. And when we are representing on a ratio scale, we are now going to take the number that is below, and then we're going to divide it with the number that is above. Meaning that we are going to swipe these digits. We are going to swipe these digits. Now we are going to say our calculation will be like this. Let me just say our calculation is now going to be 1,000, because we want to our answer to be in a ratio scale. Now we are going to supplement our digits, and then we are going to have what? Our 460 here when we are punching on your calculator. So I want you guys not to be confused when I'm coming with the answer. So this is how we calculate. So in a ratio, we are going to say 1,500 divided by what? 460. Why are we converting these sums? It is because we want our answer to be in a ratio, because our gradient is calculated in a ratio scale. Our final answer must be in a ratio. So we are going to say 1,500 divided by 460. Then the answer that we are getting here, it is 3. Meaning that our answer in a ratio form, it is going to be 1:3,3. Okay, let me not first. Okay, it's going to be 1,326. And then obviously we're going to round off, and then this is going to give us 1:3,3. And then this is our ratio. That means our gradient is 1:3,3. So now, surely in most of the exams, you are being asked to interpret the scale or the gradient or that you have calculated. So this is how we interpret the scale in words. To interpret the scale in words. So this means what? this is how we say 1 centimeter, 1 centimeter represent, okay, we are saying for every, sorry about that, when we are interpreting this scale, we say for every 1 centimeter, this 1 centimeter, you travel horizontally, because we calculated the horizontal distance. When we are interpreting this scale in word form, we say for every 1 centimeter, you travel horizontal. You rise by what? By 3.3 centimeters on the actual ground. On the actual ground. This is how we interpret our answer, our ratio scale. That for every 1 centimeter, you travel horizontal, you rise by 3.7 centimeters on the actual ground. So, if I were to award you guys the marks of this sum, this sum is usually 5 marks. So, it's going to be 1, and then you are given an answer, and then you are going to get 2 for this, and then you will get your 5 here. Okay, now guys, we'll be moving. I want you guys first to take a short break, and then we'll be doing our fourth calculation.